Hello and welcome. I remember when I took my first Java course during my freshman year in college, I was exposed to object-oriented programming, but it took me a while to wrap my head around this concept. The concept was quite confusing to me at first. Object-oriented programming, aka OOP, is one of the most important concepts in programming. It is used and asked a lot in coding interviews, so mastering OOP is absolutely crucial. In this video, I will walk you through the main idea behind classes and objects, as well as the four main pillars of OOP, including inheritance, abstraction, encapsulation, and polymorphism. We're gonna do a live demo with Python as well, so stay until the end so that you can see how object-oriented programming is implemented. So without further ado, let's dive in. So the first thing I want to mention is class and object. So a class is a blueprint of how you store your data. So for example, we may have a class called student. A class can have several attributes or properties. So a student may have name, GPA, age, and gender, for example. So these are called attributes. And a class can have several methods. So a method is like a function in a class. So we may have work, study. So each function will represent an action that the class can perform. So a student can work, a student can study. So how about object? An object is an instance of a class. We may have a student called Amy, which is an instance of the student class. We may have another student called Pop, which is another instance of the student class. The next concept I want to mention is inheritance. So this is the first pillar of object-oriented programming. The idea of inheritance is we have an object called a parent class. Parent class can have several attributes and several methods. So we assume that the parent class only have one attribute and one method. With inheritance, we can create two child class. So we call this child 1 and child 2. These subclasses will inherit the properties of the parent class. So that means in child 1, we can use attribute 1. We can use method 1 as well. And in child 2, we can also use attribute 1 and we can use method 1 as well. But let's say you want this child 1 to perform more tasks. You want it to have more attributes and you want it to have more functions. So you can always extend this by adding another attribute and another method. So this is called extension. And another thing I want to mention here is, let's say method 1 has some implementation. Let's say the implementation of method 1 is print hello. But in child 2, you don't want child 2 to bring hello to the console. You want it to do something else. So what you can do is you can use a technique called override. So basically, you will re-implement method 1 that was already implemented in the parent class. So that when you call the method 1 of child 2, it will perform the task that you want it to do. So let's say you don't want to bring hello, you want to bring hi. The second pillar of object-oriented programming is polymorphism. The idea of polymorphism is you use the same object to represent different objects. So let me go over an example to illustrate what I mean. Let's say we have a shape class. So this will represent a shape, and this shape class has a function called calculate area. So you have three child class. We have rectangle, we have triangle, and we have circle. So that means these classes also inherit this function from the shape class. That means each of these objects are considered shapes. I can create three different shapes. Call that shape 1 equal rectangle, shape 2 equal triangle, and shape 3 equal circle. Because they are all shapes, we can use s1.calculate area. We can also use shape 2.calculate area, and we can use shape 3.calculate area. So even though we are calling the same function in the shape class, it's actually trigger different implementation. So if we call s1.calculate area, it's gonna trigger the calculate area implementation of the rectangle class. If we call s2.calculate area, it's gonna trigger the implementation of the triangle class. And if we call s3.calculate area, is gonna trigger the implementation of the circle class. So essentially, you use the same function called calculate area of the shape class for all of these objects. But when you call the function in each of these objects, it triggers different implementations. That's the idea of polymorphism. The next pillar of object-oriented programming is encapsulation. So the idea of encapsulation is you sort of combine the data and the methods into one single unit called a class. So a student class can have name, can have age, can have GPA, and can have methods like work, study. This is a class. But there are certain information of the class that we don't want to access directly. So for example, a GPA. We don't want an outsider to be able to modify the GPA directly, right? So what we need to do is we need to use something called an access modifier to control the access to the variable. There are two main access modifiers that we use a lot, which is the first one is public and the second one is private. So public means anyone can use it, and private means the variable is only be able to access within the class. So if the variable is private, how can we get the GPA? So if we have a class called admin, for example, and the admin want to get a GPA of the students, how can he do that? And if he want to change the GPA of the student as well, how can he do that? So we need something called a getter and a setter. So a getter will get the GPA from the student class. So a getter is essentially just a function, right? So a function where you can get the information from the student class, and a setter is also another function where you can set a value to a variable inside the class. So in this case, the GPA. So the final concept I want to mention here is abstraction. So the idea of abstraction is you hide the implementation details of a function. So the user only needs to know what the object does rather than how it does it. So for example, we have a monitor class, and this class have two functions: turn on, which we turn on the monitor, and turn off, which we turn off the monitor. Do we actually care how this function works under the hood? No, the user doesn't care. We sort of hide implementations of this function so that when the user calls turn on, he just needs to know if the monitor is actually turning on or not. And the same thing for turn off. When he calls turn off, the monitor needs to shut down. That's the idea of abstraction. So you hide the implementation details of certain functions from the user. So that's it for the conceptual overview. I will see you in a live demo. Welcome to the live demo. I have 5 Python files opening up here. So the first Python file is class.py. So this file is used to represent a class and an object. So let's say we have a class called student. Let's say this student has several attributes such as name, age, gender, GPA. In order to define this attribute, we need to have a function called init. So in object-oriented programming language, this function is called a constructor. This function will create a student object for us. So we have name. Let's say we're gonna pass in a name variable here. We pass in the age variable, the gender variable, and the GPA. Student have name. This student have age. So self.age equals age. We assign the gender. Self.gender equals gender, and GPA. Self means the actual student. This student have a method called study. So I will make this method simple. So we bring our string. So let's say self.name is studying. So now we can create several instances of this class, aka objects. So the first object I would say is student1 will be equal to student. So we pass in the name. So the name is going to be Amy. And let's say she's 20 years old. Gender is female. And the GPA will be 3.5. The second student is Pop. He's 23 years old. He's a male. And the GPA is maybe 3.7. So if we want to see the GPA of Amy, what we can do is we can just bring now Amy GPA. So what we can do is we can take the object s1 dot and access the attribute. So the attribute here is going to be GPA, and we can do the same thing for Pop. So Pop GPA is going to be equal to s2 dot GPA. Let me run the function. So Python class So we can see that Amy GPA is 3.5 and Pop GPA is 3.7. So you can always access the attribute using the dot. So let's move on to inheritance. As I mentioned before, inheritance is a way for a subclass to inherit the properties and the methods from the parent class. First, we need a parent class, right? So let's say we have a class called employee. This class already have some attributes. The employee will have his or her name, right? We may have his or her age, and we also have salary. This employee class will have a function called work, and this function just essentially print out self.name is working. So we have the parent class called employee, and we have two subclasses called software engineer and designer. So each software engineer is an employee, and each designer is also an employee. So to inherit the employee class, what we can do is we can open the bracket, then pass in the employee class. The software engineer class and the designer class already inherit the employee class. So even though we don't have any implementation of these classes, we can use this attribute and this method. So let me show you how. So the first object I want to create is a software engineer. Let's say I don't passing anything, and let's run Python inheritance. So it say type error, employee init missed 3 required positional argument, name, age, and salary. So we can see that even though we don't have any constructor for the software engineer class, it used the constructor from the parent class, which is employee, and that constructor require name, age, and salary. So I have to pass in the name. Let's say she's 29 and her salary may be like $10,000 per month. I will create another software engineer class, so which is called Pop. He's 27 years old, and let's say his salary is $7,000 per month. I also create a designer object, designer 1. So let's say her name is Cindy. She's 25, and her salary is like $4,000 per month. Now, if I run the function again, there's no more error because we already provide all the arguments necessary to create the object. Let's say I want to extend the software engineer class because this class may have more attributes than just name, age, and salary. What else do I need? I may need level. So because engineer may have level like junior, senior, tech lead, staff. So if I want to include a new attribute in the software engineer class, I need to create a constructor for the software engineer class. The constructor is the init method. So as you can see here, I pass in the name, the age, the salary, and also the level of the engineer. So the first line of the init method is super.init name, age, salary. So what this line does is it calls the constructor from the parent class, which is this method. So that means we don't need to rewrite all of this logic. We can just reuse the function from the parent class. And we may have another attribute called level, and we're gonna assign the level to this software engineer, right? The same thing for a designer, right? So let's say each designer may have not just the salary, age, and name, but also department. So we can use a super keyword to access the parent class employee and create the object first. Then we add a new attribute called department and assign the department value that we want to have here. So that means when I create this object, I need to pass in all of the arguments. So right now for the software engineer objects, I'm missing the level attribute. So let's say Amy is a senior engineer, and Pop is a junior engineer. And let's say that this designer belongs to the marketing department. I create a new designer object. It's called Daniel. He's 26 years old. He earned $5,000 per month, and he's in the sales department. So now when I print out, let's say name is at level. So I'm gonna print out the name of the first software engineer and her level. I'm going to repeat the same thing for the second software engineer object and see if it works. Right, so Amy is at senior level and Pop is at junior level. So that works. How about the designer object? So the one name is working for d1.department. d2 name is working for d2 department. So Cindy is working for the marketing department. Daniel is working for the sales department. So that's good. Okay, that's the idea of extension. So the final thing I want to mention about inheritance is override function. We can see that the employee have a method called work, right? For now, let's call the function s1 work. Let's call the function work on the software engineer object and see what we have. We can also call that on the designer object. So we see Amy is working, which correspond to this line, and Cindy is working, which correspond to this line. All right, so let's say for now we don't want to use this function in the software engineer anymore. We want something more advanced. What we can do is we can override this function. We define the same function in this software engineer object, but now we want to bring something else. We want to bring that this person is coding. So when I bring inheritance, so you can see that the function has been overridden. So Amy is coding now. She's not just working, she's coding. And we can do exactly the same thing for the designer class. So instead of coding here, we can say the person is designing. When I run the file, we can see that Amy is coding and Cindy is designing. So that's the idea of overriding. The next concept I want to mention is polymorphism. So for polymorphism, we need to create a parent class. I'll call shape. Just have an empty constructor, so we don't have any attribute for the shape class. But this shape class, we have a method called calculate area, and we're gonna have an empty implementation for this method. We create 3 subclasses. The first one is rectangle that we inherit from the shape class, but it has its own calculate area. So we have cal area. We're going to return something. So to calculate the area of the rectangle, we need the length and the width of the rectangle. Self.length equal length, self.width equal width. I'm going to pass in length and width here. And to calculate the area, we just need to multiply them together. So multiply self.length and self.width. So we have a class called triangle, also inherit from the shape class. To calculate the area of the triangle, we need the height and the base, right? So I also call super init. I create 2 variables called height and base. And this should be a class, not a function. And we also implement the calculate area function. To calculate the area of a triangle, we need to multiply the height and the base and divide that by 2. So multiply by 0.5. And finally, I'm going to define a class called circle that inherits from the shape class. I'll create a constructor. To calculate the area of a circle, we need the radius, right? So radius equal radius, cal area. So the area of a circle will be radius times cell.radius times 3.14. So now I'm going to create 3 shapes, right? So the first shape is gonna be, so we call that shape 1, is gonna be a rectangle. So rectangle, I'm gonna pass in the length, which is 10, the width is 5. The second shape is gonna be a triangle. The height is 10, the base is, let's say, 2, and the final shape is gonna be a circle. So circle, and the radius here is gonna be maybe 5. I'm gonna create a shape array. So shape 1, shape 2, and shape 3. So now I'm gonna loop through all these shapes and call the calculate area. Alright. So for I shape in enumerate shapes. So I here is the index of the shape in the array, and shape here is the actual object. I'm gonna print out shape I area equals shape.calculate area. So let's run this and see how it goes. So the area of the 0 shape, aka the rectangle, is 50, right? So that's 10 multiplied by 5. The area of the first shape is 10, so which is a triangle. So we multiply 10 by 2 and then divided that by 2, which is 10. The area of the second shape is 78.5. So we take 5 multiplied by 5, then multiply by 3.14. So we get this number. Even though we call the same function calculate area for the shape, it actually triggers different implementation of the function. So the next thing I want to mention here is encapsulation. So the idea of encapsulation means we want to hide certain details of an object. So let's say we have a student class, and the student may have the name, age, and GPA. So if we define this variable like this, they are considered public variables. Alright, so I did mention this in the conceptual overview. We have two access modifiers, public and private. And if we define like this, Python will assume that these are public variables. That means when we create a student object, we can easily access this variable outside of the object scope. So we can do S1 name, alright, has a GPA of S1 GPA. So if I run encapsulation, alright, so I see that Amy has a GPA of 3.6. But there are cases when we don't want outsiders to manipulate these variables, right? To access or manipulate this variable. So what we can do is we can make this variable private. So the way to do that is to use double underscore. And if I run this function again, I'm gonna have an error called attribute error. Student object has no attribute GPA. So because these variables are private, we cannot access it outside of the object scope. So let's say we have an admin class, an admin object that want to access the GPA of the student. So what we can do is we can define a getter and a setter. Let's say I have a getter called get GPA. So this function just returns self dot underscore underscore GPA. And we have a setter, so set GPA, so new GPA. So this will assign the new GPA to this variable. So now, if we want to access the GPA of S1, of student 1, we cannot use a dot and then access the variable like this. We have to call the getter. So call get GPA. So when we run the function again, now we see that Amy has a GPA of 3.6. Let's say we want to change the GPA of this student. So S1 dot GPA equal, let's say 3.9. So we cannot do this, right? Because this variable is private. So we have to use a setter. So call set GPA and then pass in the value 3.9. Alright, so now when we print the GPA of this student, we see that Amy has a GPA of 3.9. So that's the idea of encapsulation. So the final concept I want to go over is abstraction. So as I mentioned before, abstraction means we hide the implementation details from the user. In order to do that, we have to use an ABC package in Python, and we have to import ABC class and abstract method. So this is a decorator, and I'm gonna define a class called monitor. So this class we inherit the ABC class. Right, so we tell that this monitor class is an abstract class. An abstract class will only contain abstract methods. Okay, so I will define a function called turn on, and this method is an abstract method. Because it's an abstract method, we will not have any implementation for this method. So that's the idea of abstraction. We don't have the implementation details. We may have another subclass called laptop monitor, and this will inherit the monitor class. And in this class, we will implement the turn on function. So what we do is we're gonna print laptop is turning on. We create a laptop monitor. We can do laptop equal laptop monitor. And when we call laptop dot turn on, we can see that laptop is turning on. So the user doesn't need to know how the how the turn on function is working. He just needs to know that when he called turn on, he can see that the laptop is turning on. Okay, so that's the idea of abstraction. That's it for this video. I hope you enjoy it. If you like the video, please like and subscribe. That supports the channel a lot, and I will see you in the next video. Peace.